All right, we are live. So let's start. Uh, Hi everyone. Welcome today to another episode of another webinar from Rebase by Recro. Today we are having a very exciting webinar with us on test loading. I know, like all of us being app users, we do have that irritation if the app doesn't work, and especially like as a performance engineer, like that, it becomes necessary that to ensure your customers to have a good experience. You need a app which is running smoothly, and that's where Mrunal here is joining us to give us a good brief on how you can do that. You can have a app without any hurdles like that. So before I start off with this exciting webinar, I'll just give a small introduction about myself and about Rebase as a community. Where this webinar is being hosted on behalf of Rebase. So yeah, hi, my name is Candida. I am the community executive of uh, Rebase, and I handle the community part. Rebase is a community of 3,700 plus developers we have in our community, where we are growing and networking with each other. As a community, we do a lot of initiative for our members in the community, such as mentorship hours, where we have more than 15 plus mentors from Google, Microsoft, etc., who comes, and give one-on-one mentorship for our members. Apart from that, we do have networking session, offline meetups, which we have. Last month, we had it in Indore. We are having one very soon, in fact, in Jaipur, which we are very much excited to be hosting that. Like that, Jaipur folks, we are very excited to see you very soon. So yeah, these are some of the things which we have part of the community and apart from the webinars which we host. So if you guys are interested, if you guys have not heard of Rebase, if you guys are interested like that, I would like recommend you guys to pop into our community, check us out. We are very much active on Discord. So I'll be plugging in the link to join our community in the comment section. You guys can join in. And over that's it. Coming to today's webinar, we have Mrunal here with us. Mrunal is a senior software engineer with around 14 plus years of experience. He have worked in companies like Wipro, Wells Frog, and so on. Yeah, Mrunal, you can maybe give a introduction about yourself.
Yeah, I'll probably start the session itself, and then one of the slides is my introduction. So I'll just start with the
Okay.
uh, that works, right,
Yeah,
Canada?
yeah, that works like that. So before we start then off with the session, I would like recommend you guys to be very active. Do post in a lot of questions because towards the end of the session we'll be taking in questions like that. So we have a lot of questions which all we got already from the community. We'll be covering that up. But then you guys can also put in your questions. Be interactive in the community. Tell us where you are from. I would really love to know that from you guys. So yeah, Ronald, you can start off the session.
Okay. Screen sharing.
Yeah.
Can I get access?
It's there, right?
It says host has disabled.
1 second.
Yeah.
Yeah, now you can.
Yes. Hey everyone, good to see you. Good morning. I hope I'm guessing all of you are from here in India. Um, so this session is going to about how can you make your application handle the pressure, right? Production pressure. Um, Before that, I'll just start with my introduction. Um, my name is Mrunal, as Canada introduced me to all of you guys. I'm a senior manager for performance engineering team at Techion. I have 14 plus years of experience in performance testing and engineering. Um, I have experience working in the service industry with Wipro and product companies like Wells Fargo, SAP and Nitro, and currently working with Techion from the last 6 years. I'm very passionate about performance. All through these 14 years, I've worked on projects relating to performance. I've delivered some large performance testing projects for some of the large retailers in US, one large insurance company in India, one automotive giant from UK and France. So currently, I am handling the team at Techion, which is the sole team that does performance for the entire products that Techion has. We have two large products, and I have a team of 17 people who takes care of all of these two products and smaller applications. I live in Bangalore with my family. I have a daughter. I live with my parents. I'm from Karnataka. I've grown in different places. I've done my studies in Raichur, which is in North Karnataka. And for my engineering, I came here and I settled down here in Bangalore. Um, when I'm free, I love reading books, and you might find, if at all we meet, you may find me playing chess, right? Although I'm not a expert, I try to engage myself in chess whenever I'm free. My blitz score is 840 right now. So if any one of you wants to connect with me on chess.com, you're free, right? So we'll start with the agenda. Um, the agenda is load test blueprint. Um, Most of us are in a situation where, we want to do load testing, but we don't know where to start with, right? We want to, uh, I mean, sometimes we just think that if I just test my API, that should be enough. But there's a lot more to performance testing than just testing your own APIs. So we'll look at what a good strategy would be for load testing. Some real world scenarios where, we see importance of performance, right? Performance testing. Um, some of the scenarios we'll see those. I'm sorry, I think I moved the screens to somewhere. I'm just trying to adjust the zoom window here so that the screen is visible to me. Yeah. So we'll take a look at some of the real world scenarios where if you are handling those kind of scenarios as part of your work, right? You will get guidance on how to test for those applications. We'll look at tool selection tips. There are multitude of tools available in the market. It's so confusing to choose the right tool for your needs. We'll look at what are the selection criteria or how to choose a tool for your own needs, right? Um, Performance metrics. So the main point of testing is performance testing is gathering performance metrics based on which you decide what to optimize, how to optimize, right? We look at some of those metrics and some of the optimization techniques, some simple things or simple tweaks that you can do, to get good performance gains. Will not touch upon any code optimizations as such. These tweaks are related to the periphery of the code, like how to organize your infrastructure, how to organize your infrastructure, or what tweaks you can make in the UI, simple things like that, which give you higher gains, right? These are the things that you should target before you get into code optimization, right? We'll proceed with that. We'll proceed with the session then. So overall, if you look at, how you should look at performance, or any company or any web application should look at performance, is two things, right? Yeah, how we manage performance strategy is by doing two things. We should have effective production monitoring, and we should have effective performance testing. Both are complementary to each other, because without production monitoring, or just having production monitoring, is not enough. You'll end up sending anything and everything to production, and you'll only do production monitoring. It's not just about monitoring, right? You should monitor, measure, and then fix as well. Coming to performance testing, it's just not enough that you test and send to production, because you can't test everything. Applications are so vast, it is very difficult with limited time and resources to test everything, right? So you test whatever you can, and then rest of it you monitor in production. It's not easy to test everything, and there will be inevitably, even if you do a lot of tests, right? Even if you try to cover 100% of functionality, there will be some or the other thing that breaks in production. So production monitoring and performance testing are two sides of the same coin, which is your performance measurement or management strategy. So we'll start with a brief on performance monitoring. Um, but majority of the focus is going to of this session is going to be the focus is going to be majorly on performance testing. We'll touch upon what performance monitoring means, what tools are available, right? Performance monitoring is the ability to understand what is happening in production, right? How your applications, how your services, how your different layers of your application are behaving in the production. Um, so this can be done by some of the tools that I've listed here. There are lots of commercial tools available. There are open source tools available. The main point of these tools is that they have certain monitoring agents which sit in your application and understand, or they constantly monitor how your application is being used and how it is behaving under the production load, right? They gather data, they analyze this data and show you in terms of graphs, charts, right? Alerts. So there are lots of commercial tools. Dynatrace is one of the most powerful tools out there in the market. There is New Relic, there is App Dynamics, there is Datadog. All of these tools are commercial tools, meaning they come with a license and you get some amount of support. They help you implement these tools in your production as well. And whenever there's a problem, you get support from the companies, from these companies to monitor your applications, or how best to monitor your applications. They give you guidance on how to do that. There are some open source tools which you can implement in your applications. These do not come with any support or anything like that. It is the onus is upon the application owners to adopt these tools and build all the infrastructure needed to use these tools. So Elastic APM is one of the most modern and a tool that has good functionality for as compared to other commercial tools, right? And one of the other important things of monitoring in production is real user monitoring. This concerns with how each user is using the application. So the above two tools are mostly about backend databases, backend infrastructure, right? How do you understand what is happening under load? Whereas real user monitoring tells you how the user experience is actually on the screen or on the browser. If something is loading slowly, is he getting frustrated, or is he there is something called as rage clicks, right? If something doesn't load quickly, we tend to click on some button with rage, right? We force click it. So some of these behaviors can be tracked using real user monitoring. This so the output of all of these acts as an input to our performance improvement efforts, right? So moving on to the next slide. Now, we just touched upon what performance monitoring is. Now we'll try to understand what is performance testing, right? We all understand how to test a functionality, right? As the user, or functionally testing an application means using it as a end user would do, right? But performance testing, those are called as functional tests. But performance testing, security testing, these are all categorized as non-functional tests, which mean they're not just about exercising a functionality. Non-functional tests means you test the non-functional aspects of your application. Non-functional aspects means security, reliability, performance, and usability, right? So these are the some of the non-functional aspects, and one of those non-functional aspects is performance. The performance testing is a non-functional test which is executed to understand how your application performs or how fast it responds. It can also help you measure resource usage. As I mentioned, one of the non-functional um, uh, attributes is resource usage. So overall, performance testing is an umbrella term, meaning all of the practices that we do under um, performance testing, they are grouped uh, under this performance testing, right? So it's a umbrella term. There are some other types of tests that come under performance testing that I'll explain in the subsequent slides. So why do we need to do performance tests, right? Performance tests are important from the point of view of scale, right? Anybody who is doing business on the internet, they are doing it because of the scale, right? You can reach hundreds of thousands of people on the internet, and at that scale, performance really becomes important from cost perspective, and even in terms of uh, the reputation, right? If like we have seen in the past, Flipkart, when they did their first big billion day sale, they were not able to cope up with the load, and the site went down. That considerably hit their reputation as a e-commerce site, right? So internet businesses are doing business on the internet because of the scale, right? And if performance is not good, you're losing reputation, you're losing money, right? Performance testing helps you validate that your application works smoothly at scale. Now, another thing to note is human attention span is decreasing with all the 30-second vines or 30-second shorts that we have. Our attention span is ever decreasing, right? And slow websites or websites that crash under load are a risk to business, right? Whenever people come to your site, if it is slow or if it is not loading or it's constantly crashing under load, people don't tend to stick to your website. They'll find other better websites, right? That is why performance testing is important. Now, as I said earlier, some of the real world scenarios, for performance testing, that if any of you are handling these kind of applications or building these kind of applications, performance testing becomes very important for your application. And you can, if you're already not doing performance testing, you could maybe take a few things from this session and start doing at your um, company or office, right? So some of the use cases or scenarios where performance testing is very crucial are these, right? Let's say you're doing a new product launch, or any sale event, campaigns, right? Recently, I mean, it's been happening less and less on e-commerce sites these days. They are able to cope up with the load. But in the past, we have seen, right, any sale event, it was a given that the site would crash, right? There are campaigns, there are new product launches. Every now and then, I see some of the car websites, they launch a new car and their website goes down because of the huge interest in the new car, right? So companies who are dealing with e-commerce, consumer goods, automotive websites, these are the use cases where you need to have proper performance testing done before your activities like product launch, sale events, campaigns. Some of the breaking news, right? Recent election results. People were constantly checking news websites for latest election results. Social media websites. In the past, I remember when I started using Twitter, it would show the whale icon or whale page where it said the site is overloaded. Even on chess.com, I constantly see that during um, a heavy load, right? In the evenings, when that is when people start playing chess games, it's the site undergoes a huge load. And there could be special days on which your website could be accessed, right? For example, all the exam results are announced on a particular day. um, Students are eager to know their results, so they flock to the website and the website goes down, right? We have seen live streaming media, um, IPL events, or any big award ceremonies. Uh, Websites hosting these kind of events also need performance testing. bulk data processing. In maybe you are running a business application or you're building a business application, there could be nightly jobs, migrations, report generation. All of these work in batches, so they also need to be tested for performance because they're business intensive. If something fails, right, your business cannot progress further. So these need performance testing. Capacity management. Most of our current applications are hosted on the cloud. So if you are not able to manage capacity for your load, you end up buying more and more cloud infrastructure, which is costly in the long run, right? So to be able to understand how much, to be able to understand or buy only the right amount of capacity needed to run your application, performance testing is an important thing to do. And performance regression. We all have multiple releases every month, every quarter in our applications. To handle any new performance bugs being introduced by new code, we do performance testing, right? So these are some of the real world scenarios where you would need to do performance testing. Moving on to the next slide. So what should be our performance strategy now that we know what kind of applications need performance testing? What should be our performance testing strategy, right? Um, so prevention is always better than cure. We have learned this in our childhood, right? Prevention is better than cure. Don't wait for a load surge in production. Don't think that you can send it to production and then worry about performance. Performance should be tested before your code is sent to production. Test it before it happens and keep your application ready for the load. In many cases, you will be aware that some load is going to come. For example, election result day, a sale event. You will know from other departments in your company that some load is going to come onto your website. So prepare for that. Don't wait and think that you can deal it in when it happens in production. So a comprehensive performance strategy would be to measure UI as well as backend, because we have seen if or it is bound to happen that if your backend doesn't respond fast, your UI is definitely going to be slow. So a good strategy, performance strategy, includes both UI and backend performance measurement, right? Because a slow backend will cause your UI to slow down, and ultimately it leads to bad experience and loss of business, right? Moving on to the next slide. Um, so what should be our UI performance testing strategy, right? How do we do, or what do we do as part of our UI performance? So UI performance is measured in the browser. If your interface to your backend application is a browser, it is done on the browser. The UI performance tests are done on the browser. You can do the same on mobile applications as well. If your interface to your application is through a mobile phone, mobile app, this can be done on the mobile as well, right? Um, the best approach to test UI is to first load the backend. You are trying to simulate the actual scenario. Usually what happens, UI slows down because something in the backend is slow. So we try to simulate that. First put load on the backend and then try to load the page and measure response time and other browser metrics at the browser or your mobile browser or mobile app, right? There are tools to measure UI performance. Some of the very popular ones are sitespeed.io, web page test, and Lighthouse. All of these are open source. There are certain commercial tools as well. I've not listed there because I don't have much experience on those commercial tools, right? So now that we know that we can measure UI performance, and it is a part of our overall performance testing strategy, we'll move on to backend testing. Backend performance testing, as I said earlier, performance testing is an umbrella term. It includes multiple types of tests. So the scale on the application can be tested using multiple types of tests. There are various aspects of scale and performance that we test through these set of tests. One is load testing. This test tries to determine how the application behaves under the expected load. For example, Flipkart must be, I'll take the example of Flipkart. So Flipkart, from the past metrics, right? They would know, they have analytics data captured. From the past data, they would know on a normal day, how would, at any given point in time during the day, what would be the general number of visitors on the site. That is expected load. So load testing tries to understand what happens or how the application behaves under expected load. Stress testing tries to understand the behavior of the application when uh, the application experiences more load than expected. So in stress testing, what we do, we try to break the application, or we try to understand where the breakpoint of the application is by increasing the load and steps. So we start with the expected load. We try to answer questions like what happens when my load doubles, what happens when my load triples, right? So we try to go on increasing the load in steps and try to see where the breakpoint is with the current infrastructure, right? Endurance testing, this is more applicable, or this is an important test for Java or JVM based applications, right? We frequently see that Java based applications experience out of memory issues, memory leaks. Those are called as memory leaks. So endurance testing is a specific test to understand if there are any memory leaks in the application. So this test involves testing or running the test for a longer duration, say 8 hours, 24 hours, 36 hours, 48 hours, right? So the duration of the test depends on how the object buildup of objects is in the JVM. So endurance testing is a test that helps you understand how the memory is being used if there are any memory bottlenecks. Spike testing, this is specifically to test scenarios where there is a sudden spike on the application. For example, flash sales, right? We have seen in the past that Flipkart or all other e-commerce sites have at some point in time done flash sales. We try to understand what happens when there is a sudden point load at one moment in time. All the load is put on the application at that time. How does the application behave, right? We all have experience with Tatkal, booking Tatkal tickets as well. So that is a type of test called as spike testing. Now we'll take a look at some of the performance testing tools. So in general, right, all of the tools work on the same principle. They apply load, they measure the response times for multiple samples. They just don't do it for one, they do it for multiple samples, meaning they repeat the same hit again and again, repeat the same test again and again, and then apply some statistical methods on the data gathered to find averages and percentiles, right? Any tool you pick, these are the basic principles on which that tool would work. And all of these performance testing tools have these basic functionalities: ability to script, workflow or API. You could do an entire workflow, like, for example, in an e-commerce application, product search, product listing page, product detail page, add to cart, place order, right? This is one workflow. So these tools give you the ability to script this workflow, or they also give you the ability to script particular API hits, right? And they give you the ability to generate a load, meaning what is load? You simulate load, production load, via multi-threading. So these tools offer you the ability to generate multiple threads, and you can spread the load across multiple machines. So this is one of the basic functionalities that each one of these tools offers. And last but not the least, ability to capture metrics. As I mentioned earlier also, uh, ability to capture metrics. When did I trigger my request? When was the first byte received from the application? How much time did it take for the entire response to load? All of these minute measurements are also tracked by these tools. So to summarize, all tools have these three. They work on the same principle: apply load, measure response times, and apply statistical methods. And some of the basic functionalities that all tools have are ability to script, ability to generate load, and ability to capture metrics. right? All tools have these same attributes. Now, some of the commercial tools, their specialty is that they offer great customer support, meaning once you buy the license, you don't have to worry about setting it up, or if there are problems with using the tool, they give you training, they help you implement the tool, right? These commercial tools come with such set of attributes. They have very powerful features which can, they can integrate with some of your ecosystem, your software stack, and they support multiple protocols. I know one tool, Load Runner, which I mentioned in the next point. It has close to 20 plus protocols, right? In the past, there were a lot of internet protocols. Now it is considerably reduced, but these tools still support 20 plus protocols. And these are suitable for very large applications like um, banks, right? They have distributed, there's something called as core banking. You have multiple bank branches which talk to each other, right? And these are the kind of the commercial tools are preferred by large customers or large companies who prefer the security and customer support over free tools or open source tools, right? Some of the commercial tool examples are LoadRunner, NeoLoad, Cloud Test, right? If you look at any bank, most most of them use LoadRunner for their performance testing needs, right? Um, Coming to open source tools, they are good with great community support. People are open source community is building a lot of plugins. They are solving issues for your tool. You can submit PRs to these tools. You can make your own changes, whatever feature you want. You can build and add to these tools, right? They are extensible with plugins and libraries. Just an example, JMeter, if you just go to their page, there are so many people contributing to this open source project. There are people writing plugins and libraries for JMeter, right? So open source tools have this vast community support. They do support a lot of protocols, internet protocols, but as compared to commercial tools, the number is limited. They usually support HTTP, TCP, WebSocket, and few other protocols, right? Um, these tools are popular among small and medium-sized companies like startups, right? They prefer, instead of investing in large commercial tools, startups prefer using JMeter, K6, or these open source tools. Some of the open source tools that I know of are Apache JMeter, K6, Locust, Gatling, and all of that. So each one of these have all the basic functionalities that I mentioned in the previous slide, but they also have some specialities over each other, right? K6, Locust, and JMeter are really easy to get started, and they can give you, like, they have the capability to generate good amount of load, heavy load, to the tune of thousands of hits per second, right? You can, with good amount of infrastructure, you can generate thousands of hits per second, and they provide accurate performance testing results. Okay, moving on to the next slide. So, okay, now we know what is performance testing, what tools we have in the market, what should be our approach to test, and what should we test? Like, right, we'll look at answering these questions. So if you look at this picture, right, if you look at, this is a picture of a feature development, let's say a very simple feature development, right? You conceptualize the feature, you design the code for it, you do high level or low level design, you start developing, and then you start testing, and then you release it to the customers. If you look at the bugs, right, it's constantly growing by the time you conceptualized it and by the time it went to release. This means that if a bug was present in the conceptualization stage, if you don't fix it, or if you didn't find it, it becomes so big. By the time it goes to release, it becomes very costly to, the y-axis shows you the cost of fixing a bug, right? It is 10,000 times harder or costlier to fix when a bug goes to production or release. So looking at this, what should be our test approach? So there are two approaches to doing performance tests. One is, the first approach is test early, test often, right? it is good to start running local tests when you have the first pass or first draft of your feature written. You can start running some local load tests with a small scale, right? You can test how a particular method that you're using is performance, how much time it is taking, or the set of data structures that you have chosen, how are they performing at your local level. You can start with these small scale tests, load tests. um, the tools that I said earlier, the open source, especially the open source tools, help you test this as well as larger scale tests, right? So at your level, you can test early, test often. However, there is another approach. In addition to this, testing early, in addition to this, in testing early, you can find any smaller bugs which you could find. But the other approach where it's a supplementary approach where you test the entire application end to end, right? That test helps you find any integrate bottlenecks at integration points or performance bugs at integration points. Those will not be local. Those bottlenecks show up, or those performance bugs show up when you integrate with other part of the code, right? That is actually, I mean, it is your performance test approach should be the combination of local tests and end-to-end tests. Okay. So now we know, okay, how to test or what should be our approach to test. Now, what do I test? How do I cover how do I achieve my test coverage, right? Uh, if you, as a developer, you understand what functionality you are building, or as a tester, you know what functionality you are building, right? So, cover the most frequently used functionality. You will know that, for example, for an e-commerce, it could be a landing page, or it could be a search functionality, right? That is a most frequently used functionality. Uh, there could be some functionalities in your application where you have very resource intensive use cases, right? Um, like bad jobs, migrations, long running DB tasks. So these are some of the tests or use cases that you can cover. And there are business critical use cases. These are cases where it is absolutely uh, not negotiable that these use cases go down. So three types of use cases you have to cover in your performance tests: those that are frequently covered, frequently used, those that are resource intensive, and those that are very important for your business, right? Performance tests need not cover all of the functionality. The above pointers that I mentioned cover about 20% of the functionality that causes 80% of your performance problems. So you can rely on the 20-80-20 rule, where if you cover just the 20% of the functionality that is causing 80% of the performance problems, you are good enough, right? Moving on to the next slide. So now I know what to test, what tools to use, what should be my strategy. Now, how to ensure that you're testing the right thing, right? Or how to make sure you're getting the right results. So that you do by taking some of the precautions or some of the best practices. Some of the best practices when performance testing using all of the tools that I mentioned earlier are: you have to randomize test data, because in production it's not that the same request is being triggered all of the time or same user is doing all of the activity. No, it's multitude of users doing multiple things at the same time, right? So you should randomize your test data. You should simulate expected production load as close as possible. It's not possible to do the exact same load, but you should get as close as possible, right? If in production you are receiving 10,000 hits per minute, you should come to that number as you should simulate that number as close as possible, right? Your test duration. So you might ask, how long should I run my tests? The test duration should be long enough to offset any caching, any effects of caching, right? All of us, if I mean, without our knowledge, maybe some of the components in the libraries that we use have some amount of caching, right? Our test should be long enough to exclude the effects of caching. So 1 hour is generally a good amount of time, but if you can't wait for that long, at least 15 to 30 minutes is a must for any load test. Make sure your tests include warm-up of the application, especially for Java. Java performs best when it is warmed up, right? So initial few minutes of the test, you should hit the application so that it warms up to your requests. Otherwise, the results could be skewed. If you just start your test without any warm-up, you may see skewed response times or skewed results. If you have time, if time permits, test for consistency. This is because a lot of random things are always affecting our test results. You should test for consistency. Run the same test twice consecutively to get some consistent results, right? Test your application from a distance as close as possible. Meaning, if your application is hosted somewhere in the US, right, your load generator, the tool that is generating load on your application, should also be running in, or it should be running your scripts in the same location as, let's say, your application is hosted in US California. Your test should also be running in US California. That removes the latency part, which is um, which should not be accounted into the test results, right? Load generation for large tests. Earlier I mentioned you should run local tests that will help you catch smaller bugs. But when you're running larger tests, the load generation should come from individual dedicated machines and not from any shared infrastructure. This ensures that your load generator, or the tool that is generating the load, is only doing that part. It is not being affected from any other work that it is doing, right? This is how we get good results, or this is how we can avoid, by following these good practices, we can avoid skewed results. Where to test? Again, coming back to the how to test or where to test. As I mentioned earlier, smaller tests for single functionality can be executed in local or lower environments. Large load tests, which simulate production load, should be run in a production-like environment. With proper guardrails, load tests can also be done directly in production environment. There are companies which, in off business hours, they load test in production because they already have a infrastructure set up. They prefer to run tests, but with some guardrails, the data that you produce during your load test should be reverted back, right? It should not affect production data. So with some of those guardrails, you can test in production as well. Coming to metrics, now I know what to test, how to test, how long to test. Now, what measure metrics should I look at? We start analyzing performance of the application with the below metrics. Now, let's say I have done my test. Now I have some metrics. What should I look at in those metrics, right? The primary metrics that you should look at are: what was my throughput? Higher throughput is always better. Throughput means amount of work that your application was able to do in unit time. For example, if you are hitting an API, you're trying to understand the performance of an API. If I say my API is able, my service is able to process 1,000 requests per second, that measure is called as throughput. Response time, it is the amount of time it took for your service to, or your API to respond, send me the response. That lower is better, right? Always. We want everything to be fast. So lower is better. Error rates, we inevitably have errors in our applications because of a lot of things. So lower error rate is better, right? When when these results are expected, or these metrics are expected, we don't usually get deep into the other metrics. But if we see problems, we see lower throughput than expected, we see higher response time than expected, we see higher error rates than expected, we dig deep into the next set of metrics, which concern with the application, the database, or other layers of your architecture, right? Um, so in application, you can measure what was your CPU utilization, what was your memory utilization, disk, network utilization, right? What was your thread count? You may have services which have certain thread counts. There could be thresholds on those thread counts which it is exceeding. There could be heap if it is a Java or virtual machine based language that you have in production. You could look at heap utilization. How was it behaving? what were the garbage collection times, what was the garbage collection frequency, right? These are some of the metrics that you can dig deep into to understand why your performance was bad. These are some of the database metrics: query times, query rates, cache utilization, logs, index utilization, right? So there could be multiple layers in your application architecture. There could, a lot of such metrics can be listed for each layer of your application. So it is best that with this comes from practice. You have to interact with, you have to run multiple tests to understand what each metric means, right? And then you choose that metric to as a reflection of your performance. um, Refer to metrics documentation of each layer of your application, right? Now, uh, now that we saw, right, there could be multiple layers in your application, and bottlenecks can occur wherever in multiple layers. Now we'll try to put or categorize where these bottlenecks could occur, right? Based on the layers in your application, bottlenecks may occur at any of the below areas, right? You may have load balancers. Your bottlenecks can occur at load balancers. Your application could be running on a VM, for example, in AWS EC2. Yeah, it's a VM. Your application could be running directly on a VM. You could be having a web server where your threads and workers are not behaving properly. Your application thread pools, database connection pools, database queries, caching layers, search layers. So these are some of the areas. If you have a good picture of your architecture in your mind, you could go check each one of these areas, how they were behaving under load or when you're running the test, right? These are some of the areas where these bottlenecks lurk, right? So one thing to notice, uh, so at many of these layers, when these are being set up, right, we don't explicitly tune them for our use case or our load, our kind of load. Most of these layers are set to default settings out of the box. They mostly work well with the default settings, but you should be aware of those default settings or the assumptions with which those default settings were set. Otherwise, they could cause bottlenecks, right? You should be very well aware what are your thread pool sizes or whatever default values are set. Now, you might be thinking, okay, there's so much of metrics that I need to remember, right? You don't need to recall or by heart all of those metrics. There's an easier way to do it. So, excuse me. So any infrastructure, so your architecture is composed of multiple infrastructure pieces or layers, right? Any infrastructure piece that your code touches or your request goes through has only four finite resources, right? So what I'm trying to tell you is that instead of trying to recall, remember all of those metrics for different layers, you can simplify that through first principles, right? Any layer or any infrastructure component that your request passes through has only four finite resources: CPU, disk, network, memory. Anything you take your database, it has its own disk, it has its own network connection, it has its CPU, it has its memory. The database engine is the software that runs on this, right? So for any infrastructure piece you take, these are the four resources that you need to take care of. So how you do that, how you ensure performance is by allocating any of these resources as late as possible, by collecting these resources back as soon as possible. You use all of these resources as less quantity as possible, and you use these four resources as less frequently as possible. So this mental picture, if you have, any application that you write will be performant, right? I'll just give a quick example. So I said you should, as less quantity of all of these resources as possible, right? Let me take the example of logging, right? You have disk, right? Your logs are written to disk. If you do a lot of logging, your disk is going to be used a lot. So that's an anti-pattern for performance. So use less quantity as possible for any of these resources. Okay. Now, some of the tricks and I'm sorry. What could be the uh, tricks and tips to tips and techniques to improve performance? There are a lot of tweaks. As I mentioned earlier, you don't need to refactor your code for good performance. There are a lot of things that you can do before touching the code, which can improve your performance, right? Some of these, we'll start with the UI first. Reduce frequency and size of data sent and received from the UI to backend. Some of the things that you can do, this is a basic principle. Reduce frequency and the data size that you send and receive on the UI. How do you do that? You cache static assets in your browser. You use a CDN to serve static content. You gzip the response, right? There are some compression algorithms available for browsers. You use those, and you minify your CSS and JSS files. These are some of the best practices for UI performance. Use the latest network protocols. HTTP 2 is the latest. HTTP 3 is also available, but wide availability is not yet there. So your best bet is HTTP 2. Use it with all the related best practices. Move your backend infrastructure closer to the user. So if your user is in US California, host your application in US California. If your user is in Mumbai, India, host your application is in Mumbai, India, closer to Mumbai, India. Right? This reduces the network latency for backend requests. Tweaks for backend and databases. Use load balancing. I'm sure any modern application would have load balancing. Determine the Determine and use the correct number of web server threads or workers, right, for the load that you experience in production. Use thread pools with adequate sizes for parallelizing tasks in your applications, right? You can make use of thread pools. I'm sure all of the languages have support for thread pools. Use them, of course, with the best practices. Minimize network calls within the application. Again, if you can reduce the network calls inside the application, do it by way of caching. Determine and use correct resources, correct resource application. So as I mentioned, you need to run tests. Only then you will be able to understand how much memory your application needs, how much CPU or network bandwidth or disk your application needs, right? Use adequate timeouts for network requests, database queries, connections. Otherwise, if you don't have timeouts, if there is an error, your request or your database query or connection is going to be stuck, and it will just hog resources, and it will make the application even slower. Use database indexes to increase read query times. Um, this is a extensive topic, but using indexes actually helps with reducing the read query times. Use adequately sized database connection pools. Connection pool is another good pattern for database usage. It is good for performance. Use them with the appropriate size, connection pool size. So to summarize, I'll there is a long list of things to do, right? I'll summarize all of that in this page. Managing application performance is important for business. It can be achieved by continuous monitoring testing. It's not just for uh, you know just for fun that we are doing performance testing. It is a business critical thing to do. If your site goes down, it is an embarrassment, it is a loss for your company. So it is to be managed appropriately by doing continuous monitoring and testing. Prevention is better than cure. Always test for performance before sending to production when you expect high scale. Start with your performance goals in mind and then select the tools. I mentioned a lot of tools, commercial tools, open source tools. I mentioned what their strengths and weaknesses are. Based on your goals, how you want to achieve your performance objectives, you can pick one tool for your use case. You can improve what you measure, right? So choose the right performance metrics. What do you want to optimize? You want to optimize throughput, you want to optimize response time. Based on that, you choose your metrics and then go about improving your application. Target low hanging fruits before optimizing code. So getting straight away into code is not advisable. You can optimize a lot of other things before you try to refactor your code for performance. Focus on optimizing performance for entire flow rather than individual components of the flow. So it so happens that you're seeing slowness on database, you fix the database or you add more capacity to the database, something else slows down, right? Bottlenecks always move in a workflow. Bottlenecks keep moving, so it's always best to optimize for the performance of entire workflow than optimizing a focused component of the flow. Performance testing and monitoring is a continuous process like all other activities in software development. So it is a regular exercise. You can't say, I am done with performance at any point in time. As your application evolves, you should also do continuous performance testing, right? So I'd like to, uh, okay. So some of the skills that help performance engineers are, you need to know fundamental skills. Like you should understand how the OS works, how the database works, how networking works, how your virtual machine in which your code runs. These fundamentals are absolutely necessary to become a great performance engineer. Understand your application architecture so that you can visualize where your request is, how your request is flowing, where it could be blocked, right? You should know basic statistics to understand what averages and percentiles mean. When you run your tests, you get a set of results which has averages, percentiles, samples, right? You need to know basic statistics to understand what those numbers mean, right? You should know your tool well. Once you adopt a tool, get to know what assumptions and defaults are there in the tool so that you can mend it as per your wishes. You can change some of the tools, you can extend the tools as per your wish. No performance anti-patterns. As I said earlier, many people don't know what a connection pool is. They don't use connection pools. So that is one of the anti-patterns, right? You should know what anti-patterns are there for performance so that you can see whenever there's a bottleneck. You can quickly identify whenever there's a bottleneck. So I'm an avid book reader. I would suggest you guys read these books to understand performance or software development in general, right? Some of these books are How to Make Things Faster by Carrie Millsap. If you want, you can take a screenshot if you may not remember later. Java Performance, the definitive guide. The application that I work on is a Java application, so I am reading this book currently. Designing data intensive applications. This book, you can say this is a like a Bible for building distributed applications. This also has a lot of pointers to improve performance. You can read this book. The Phoenix project and the Unicorn project. This in general help you understand how large applications are built, right, and maintained. Every computer performance book. This boils down all the performance concepts into a few things that you can keep in your mind at all times, right? Um, so I do one-on-one mentoring. If you're interested in getting mentorship from me, you can reach out to me or you can block my time at topmed.io. With this, I'd like to end my session. I would like to thank Candida and Recro for helping me run this session. And I would like to end this session with a quick joke, but it seems to be very slow. So thank you all. I'd like to answer any questions that you might have now.
Yeah, Mrunal, that was actually a nice joke. Yeah. So in our audience, actually, Yash have given us three questions in the Q&A, this thing. So we'll take up that question first. And then, we did have a lot of questions from the community as well. We'll take up that. Meantime, folks who all are live on LinkedIn, you guys can share your questions. We'll take that up live according to our time. If not, then, join into our community like that. We'll be taking up the questions then later on after the session gets over, right? So we'll just quickly hop on to the questions. So the first question Yash is asking, how do you estimate the load for performance testing, as in most service companies we are not always given such data, but it still falls on our head if
Yeah.
the site goes down?
Yes. I've been in this scenario, yes. So it's not, I wouldn't say it's a technical thing. There are two parts to it. One is technical and another one is slightly political, or it depends on how you influence people. Uh, you can, as an engineer, you can try to reach out to people who are closer to the application, business analysts, managers, development managers, or people who are maintaining, support people who are maintaining the application, or if there is APM tool installed in production, you can analytics tool installed in the production, you can try to get access. That is the people part of it. The technical part of it, if you don't have an estimate, regardless of whatever you do, if you don't get an estimate, you can start with the nominal load, right? You're just testing waters. You start with, say, 100 users or 100 TPM, and spread that load across your user scenarios and see what happens. And gradually, you can increase the load and try to break the application. So at least you get to know where the application breaks, and that you can give as part of your test report, right?
All right.
Um, yeah, I hope that answers your question. Yes.
The next question is, how do you judge there is an actual memory leak? Can you please explain the steps for it? Also, you mentioned memory leak mainly happens in Java. Can memory leak also happen in Node.js based on applications as well? Can you share such experience if you have?
Yeah. So in most cases, the primary indicator of memory leaks are out of memory exceptions. Okay. Or if your application is not able to release any memory. So OOMs are the result of out of memory situations are the result of memory not getting released back to the JVM, right? So you can look at the patterns or exception. One way of looking at or finding memory leaks is the OOM exception. Or if you're not getting OM exception, if you look at your monitoring graphs, you will see a constant increase in memory usage. So this is a primary indicator of an OOM. Uh, Debugging OOM involves a lot of steps. You can take, especially for Java, I'm talking from the experience from Java. You can take heap dumps and analyze what was happening. Heap dumps are snapshots of memory at that point in time. So you can try and understand. There are tools to analyze heap dumps. So you take a heap dump and you try to analyze which object or which class is holding most of the memory, and you can work on that. This is a code-based optimization. So, I mean, most Java applications do have these problems, and this needs a lot of in-depth analysis by way of taking heap dumps. You could do profiling with some tools like Visual VM, right? It's a bigger problem to solve. And Node.js, any virtual machine-based language will have memory leak problems. I think Node.js, as far as I know, Node.js also runs in a VM. It might also have a memory leak problem, but I'm not aware of the set of tools that help you find memory leaks in Node.js. So I'm not the best person to talk about Node.js, although I have experience with Java, which I explained earlier.
All right. Then what would be the process for performance testing for already existing functionalities? For example, if I build a functionality and it performed well for the load and at that given point of time, but after a few months or years, the load increases. So how often should I retest the performance for such features?
Yeah. So I covered this point earlier in my presentation. I did say that test early, test often. Even though some feature has not been touched or actively worked upon, it should be if it falls in the frequently used, resource intensive or business critical categories, it should be in your test suite. It should be part of your regular tests, regular release tests, right? Um, your release cycle could be monthly, quarterly, or every once in every 15 days, right? If if your functionality falls in frequently used, resource intensive, or business critical, it should be part of your test suite, performance test suite, and it should be tested every release. So that's how you approach it. Yes.
Then we have one more question. How best we can learn about performance engineering concept? Is it just is it just about reading or understanding the concept, actually trying to do something hands-on learning, perhaps?
Yeah. So as I mentioned in my slide, the skills for good performance engineers, you should know the fundamentals really well, because bottlenecks don't just appear in the application that you're testing, right? It could be in the OS, it could be in the database, it could be in the network, right? If you know these fundamental concepts, if you understand how a TCP connection happens, how HTTP works, how database engines work, what are the assumptions they were built on, or what are some of the things that OS prioritizes, how Java threads are spawned. If you have a grip on all of these things, all of these fundamentals, it is easier to do performance engineering. You can, all that you have to do is test, measure, and apply your learnings from these fundamentals to solve those problems, performance problems. So, in my opinion, knowing fundamentals is the best way to do performance engineering.
Okay. So we just have little while more time. I'll just quickly we'll just run through the questions which we got from the community. Uh, yep.
Yes.
So the first one is how test loaded in web stock application works.
Can you repeat that?
How test load in web stock application works.
Web stock.
Mhm.
I'm not sure I understand the question. Um,
Okay. Uh, okay, we'll move on to the next one. How do you close a session if thread block is more than 2 minutes?
yes. So this is one of the anti-patterns, right? If your thread is blocked for more than 2 minutes, it's an anti-pattern. That it means that some of the best practices for threading is not applied. So in one of my slides, I mentioned that we should have timeouts on threads, connections, all of that. So if you have the right adequate timeouts on threading, connection pools, or whatever, your thread will not get remain blocked for a long time. So the answer to this is you should have timeouts on your threads so that your uh, blocked thread doesn't hog other resources.
Uh, like the first question, actually, it's WebSocket, not WebStock. So how
Oh,
does test load in WebSocket application works?
okay. The open source tools and the commercial tools both have support for testing WebSockets. WebSocket is just another protocol, right? It works slightly differently than HTTP, but there are protocols inside these tools which help you test WebSocket as well. WebSocket is a perpetually open, like it's a channel between the client and the server. There are protocols inside these tools that I mentioned earlier, which help you test this. There are small details that you need to take care of, authentication and all of that, and these can be tested. The tools support these WebSocket protocol.
Okay. Uh, one more. Currently, we use AutoCannon to do load testing. Are there any other great tools that you would like to share?
Yeah, I read about AutoCannon. I've read about AutoCannon. I think it's a Node.js based tool, but I'm sorry. Its use case is specific to just single API testing. As I mentioned earlier, if you want to maintain the performance of an application, your strategy should be that you test it locally and then you test it end to end. This autocannon could fit in your local testing, but when it comes to end-to-end testing, JMeter, K6 are much better tools.
Okay. Uh, Coming back to tools recommendation itself, best tools need to test load. What measure makes the application to do more load programmatically?
Yeah. Um, so the tools I've already mentioned. My preferred tool is JMeter, but it needs a lot of resources to generate load. There are other modern tools. K6 is one tool which can generate more load per resource that you give it to. Um, the Can you repeat the second part of the question, Canada?
What measures make the application to take more load programmatically?
Yeah, programmatically, I mean, as I said earlier, getting into code can't like uh, it's a complex thing. I would prefer improving performance by adjusting the surrounding, the whole infrastructure rather than getting to code. That code, changing code or refactoring code for performance should be a last option. You can improve performance by following some of the best practices and measures that I mentioned in techniques and tips section of the session.
All right. I think the other questions you have already covered up in the this thing. So there's
Mhm.
just one more question I'll take up. Some best amazing load test examples that you have seen or encountered.
Um, so generally, when the scale is really large, right? For example, Google scale, Netflix scale, they it is a setting up that test infrastructure or test environment is actually very expensive, right? For that reason, what these large companies do is they set up something called as a canary environment, which is a small subset of their production environment, right? They send traffic to this canary environment and measure metrics. So they're safeguarding their majority of their users by not sending them the uh, new code that they know how it will perform. So first they send it to a small subset of people. They measure the performance, and if it is performant, they send it to larger group of people. So at large scale, this is how performance testing is done. But at a smaller, when I say large scale, it is like Earth scale, right? Google operates at Earth scale. Netflix has millions of customers. They watch movies at a time, right? So this is a practice followed at that scale, but a slightly lower scale. Like for example, in the application that I'm currently handling, the scale is around 10,000 uh, hits per second. So we cater to a lot of car dealerships in the US, right? We have a B2B software that is used by car dealership across US. So there we have like thousands of dealerships using our software. So that scale uh, is what I have seen that is around 10 to 15,000 hits per second. So this kind of scale, like if you don't have the proper automation in place to measure, because your application architecture is spread across multiple layers, when you're testing, many bottlenecks come up, right? And you should have built the automation which can capture all of these bottlenecks at each layer. Without that, it is going to be a futile effort. It will be a wasted effort. So the interesting part is bottlenecks pop up from all of the layers when you're running such large load tests. So you should be aware that you will face such situations before you plan, and you should plan to automate capturing metrics across all of this. If you have a commercial APM tool, it does all of that for you. But as I said earlier, it is very hard these are licensed tools, and it is very hard for small or medium companies to buy these tools. So you should build in-house automation to capture all of these metrics. So they are interesting. Once you get the hang of it, right, you will enjoy running load tests, such large load tests.
Mm.
I hope that answers the question.
Yeah, I think that's it to the questions. If you have guys any more questions, you can come into the community. You can share it there. I'll be more than happy to share it with Mrunal, and we can we let's just continue the conversation even after the session ends. We can continue the conversation, lead the conversation about load testing in the community like that. I'm sure like Mrunal also will be happy to join in with the conversation.
Definitely.
Also, the resources we'll be sharing it over the whatever the slides and everything PPT that has been this. We'll be sharing it in the community. So yeah, you guys can come there. Lead the conversation there as well. Like that would like to interact with you guys there. I have plugged in the link to join our community. You can, in the comments, you can like join the community as well as I have shared Nal's LinkedIn ID also. Do connect with him. Get to know him also even beyond the session. Let's take things beyond the session as well, right? Yeah, Mrunal, it was really glad to have you here. It was an insightful session. I'm pretty sure a lot of people got a lot of value from this session like that. So thank you for spending your weekend with us and, for an insightful session. Thank you so much. Yeah, that's it, guys.
Uh,
Have a good weekend. Do you have anything last that you would want to share?
Yeah, I just want to thank all the
Yeah,
attendees for coming, and I hope you got something from this session, and I hope you apply that and improve application performance at your company. Thank you.
all right. So yeah, hope to see you guys. Whoever have not yet joined Repays, hope to see you guys in the community. I look forward and seeing new faces join our community. Yeah, that's it, Mrunal. Thank you so much. For the session. Everyone have a good weekend. You too, Mrunal. Have